Good afternoon, everyone. Welcome to our third installment of the Education Helpline, where we are here to help you through the next several weeks as we navigate these very challenging times, both with our education and just life in general. So thank you for joining us. We are going to be presenting over the next several weeks different science topics, lessons, curricula, activities you can do very easily in your own home. So if you are a teacher, if you are a parent turned teacher, if you are just a lover of science, we hope that you can use some of these activities to both learn and also enjoy learning and also have some fun along with it. So my name is Evie Bell, and I'm the Marine Education Specialist with the South Carolina Sea Grant Consortium, broadcasting live in very rainy downtown Charleston this afternoon. So again, if you're just joining us, this is our third installment of the Education Helpline. So we really want to be here for you and give you some new ideas and also support you as you navigate these next several weeks of teaching. So what we have, my silent partner, Kristen, she is manning the comment box this afternoon. So it's a helpline for a reason. So if you have a question about the activity that we do today, please feel free to ask in the comment box. You can also ask about the actual science concept that we're talking about. If something's not clear, you can also just tell us hello and where you're from. That would be great too. So let us help you with the next few weeks, and please let us know how we can help you. So if this is the first time you're joining us, the way this works is we will be presenting on a particular science topic. Everything that we are presenting you can access on our website. If you go to our education page, you'll be able to download any of the curricula or resources or activities that we are presenting for free. So you can access those and more based on the topic that we're going over. Also, these videos will be archived on the Sea Grant Facebook site. So if you missed this session or you want to go back a couple of weeks ago and see what we did the past 2 weeks, you can access those videos at any time. Eventually, they're going to be on our website as well, so you can access those videos to go along with the activities that we're doing. But also feel free to hop on and hop off. We know that life happens and you don't have to sit here for the next 30 minutes. You can certainly take a break and come back. As I said, you can get this video at any point in time. So definitely enjoy, and thank you again for joining us. So the last 2 weeks, we covered two very different topics. Our first week, we covered marine debris. We have a marine debris curriculum guide, and we focused on some activities that had to do with impacts to wildlife. Those sometimes mostly negative impacts to wildlife having to do with marine debris. And then last week, Kristen did a great several demonstrations on buoyancy. They were STEM challenges that looked at buoyancy and how to create something that's buoyant, something that floats as opposed to sinks, and then also something that was neutrally buoyant, so it didn't float and didn't sink. So those are some really fun activities, and if you missed those, again, you can check out our education page and download those activities for use. Everything that we're doing, that we've done in the past few weeks and what we're doing today, we've kept them very simple. It's not because we're dumbing down the science, but we're just trying to keep the materials to a basic, very basic, so that you don't have to go out and spend money. You don't have to leave your house if you're not comfortable doing so. And you should have these items hopefully lying around your house. And if not, you can modify and still get the same result. So we're using very basic things over the next several weeks. The science is still there. It's just we're trying to keep that logistical part of it simple so that you can still learn the science and not have to worry about all those other details. So welcome again if you're just joining us. This session is going to start off a probably a 7 to 10 week series where we're going to be focusing on the one of the 7 ocean literacy essential principles. Now, you've never heard about the ocean literacy essential principles. Don't worry. It's a great resource, and Kristen will probably post that web link here in a little bit, but there's 7 overarching themes that every person should be aware of as we are connected to the ocean. There's 7 overarching topics that really emphasize how the ocean impacts our daily life and also how we impact the ocean, either positively or negatively. You don't have to be an expert in ocean sciences to understand these concepts, but it's just to make everyone aware about how important the ocean is to our daily lives. And it doesn't matter if you live on the coast, and it doesn't matter if you live in the middle of the United States. The ocean very much impacts our daily lives. So with that, we are going to focus every week for the next several weeks on one of those ocean literacy essential principles. This week, and in honor of Earth Day, we are going to be focusing on the first one, which is the Earth has one ocean with many different features. Now, I'm going to say that again. I want you to figure out what's a little bit interesting on that. If I can get my globe, have to bear with me. I'm not used to doing this like this. So the Earth has one ocean with many different features. Now, I don't know about you, but when I was growing up, I learned that there were 4 oceans: the Atlantic, the Pacific, the Arctic, and the Indian Ocean. And I just said there was one ocean. So who's right? Who's wrong? And the answer is we're both right. So on this globe here, there are 4 oceans that are labeled on this globe here. But I am going to prove to you right now that we actually do have one ocean. Okay, just one ocean. So you can do this activity too. And I know most of you probably don't have a blow-up globe lying around your house. You might. So if you don't, you can actually do this with a globe that's stationary on your desk, the one that spins around. You can do that, use that. Or if you have a map of the world hanging on your wall, take that down and then fold it, curve it, don't fold it, but curve it, tape it so that the ends meet and they match up, and then you kind of have a globe that way. So what you're going to do then is you are going to pick a spot in any ocean, okay? And bear with me because I do this differently every time, and I'm doing this backward. So I'm going to start off in the Pacific Ocean, and I'm going to show you that I can actually go through every single ocean and start and end up right back where I was without crossing land, okay? So bear with me. So I'm going to start my journey in the Pacific Ocean, and I'm going to travel down. I'm going to rotate my globe so I can see down south around Australia, and I am going to come up, and oh my goodness, look at that. I am now in the Indian Ocean. Look at that. Didn't go over land, and if I did so accidentally. Didn't go over land. So I'm going to stop off in the Indian Ocean for just a quick second. And then I'm going to continue on over. I'm going around the Horn of Africa here. And I'm going to wind up here in the Atlantic Ocean. Look at that, right there, Atlantic Ocean, right there. I'm going to whiz on by the coast of the United States and go on up, crossing right between there and Greenland up to the Arctic Ocean here. And then I'm going to bebop my way back down, and look at that. I'm right back down in the Pacific Ocean. Okay? I didn't cross over land at one time. So we have one ocean. Now, why do we have the different names? It's not wrong. So we have the Pacific Ocean, we have the Atlantic Ocean, we have the Indian Ocean, and the Arctic Ocean. It's really great to have these names because not only do they provide a geographic reference. If I just said I'm going to go do research in the ocean, that would be kind of confusing because I don't know where I'm going. That's really non-descriptive. So having names for different parts of our one ocean is really helpful to pinpoint exactly where we are. Also, every ocean has its really distinct characteristics and unique plants and animals and unique geologic features. Every ocean is very, very different. So it's okay that we have labels for the different parts of our ocean. So for example, if we were to drain the ocean, say we were to drain the Atlantic Ocean, look back around, the Atlantic Ocean here, if we were to drain the Atlantic Ocean, we would find the Mid-Atlantic Ridge, which is basically a mountain range. That's pretty cool. So it's a very prominent feature in the Atlantic Ocean. If we were to go bebop on over here to the Pacific Ocean and we drained the Pacific Ocean, we would actually find the deepest part of the ocean. So that is very, very cool stuff. If you go up to the Arctic Ocean, very interesting plants and animals that are adapted to live up there, and the same with the Indian Ocean. So every ocean has its own very unique features. So by naming the different parts of our one ocean, that's totally fine. But just to keep in mind that we're all connected by this very amazing one ocean that we have here. Lots of different features. So our first activity that we're going to do is called the globe toss. And just like what the title says, we're going to be tossing a globe. Now, it's not really fun to watch me toss it to myself for this activity. So I've kind of skipped ahead a little bit on some of the data that we are gathering with this activity. This activity can be from very, very young ages, first grade, second grade, if they can catch a ball, that's good, on up to high school. Or even adults. I like to use this activity a lot with teacher workshops and also right before certain classroom programs. It's a really great way to set the stage. The purpose of this activity is to answer the question, are we on a water-dominated planet or are we on a land-dominated planet? Okay, so we're gonna figure that out. So I'm going to sit down and show you what I'm doing just so you can see the demonstration here. So in the actual activity, it talks about the size group that you need to do this with. You can do it with yourself. It's really boring if you do. I recommend one other person in your family that you do this with. You can also do, once it's safe to do so, once we're able to get back into larger groups, you can do it as much as 25 to 30 people. So it's completely fine to do very few people or a lot, a bigger group. So the point is, with the globe toss is you're going to toss it to one person, have everybody stand up, have them kind of space themselves out around the room. It doesn't have to be a circle, just randomly space themselves out around the room. And then you give the instructions that when you toss it to somebody, when they catch it, they cannot move their hands. So I'm going to pretend like I'm catching the ball. Hopefully I'll catch it. Okay, so I've caught the ball. I'm not going to move my hands. Now, the instructions are to find out where this thumb, my left thumb right here, where it landed. Did it land on water or did it land on land? And so you do this. So since my thumb landed on water, I would put a check mark in the column on the data sheet that says water. And so you do these tosses repeated amount of times doing the same thing. So toss it to another person. They look at where their thumb is. It's on water. They do it again. It's on water again. If it happens to hit land, you would put a check mark in the land column, okay? So you can do this as many times as you want, as many repetitions as you want. The more repetitions you do, the better, but you don't have to. For simplicity's sake, I did 10 repetitions, and yes, I did this. I'm an honest Abe, so I did this earlier, and I tossed it to myself 10 times, and I actually got this these data points here. So I have 3 check marks in the land column, 7 check marks in the water column. Okay, now, what's the point in all this? So if you have very young kids, you can ask them just to count and see which column has the most check marks. And they will count, hopefully get to 7 in the water, 3 in the land, which has more, the water column. If you have older kids, you can do percentages. You can do fractions. You can do percentages. So if you were to do that, looking at these numbers, you would have 30% land, 70% water, okay? What that means is that the probability of you landing on land is 30%. The probability of you landing on the ocean is 70%. what that means as far as this exercise goes is that the ocean does have roughly about 71% covered with water. So we do live on a water-dominated planet. And so the more repetitions you do, the more chances you have of your thumb landing on water. So if you find you're doing this activity and you're getting way more lands than you are waters, one tip is to continue the repetition, do more repetitions until you get a little bit more water check marks. It doesn't have to equal 70%, but as long as you get close enough to that average, then you can stop the game and talk about how the ocean is 71% covered with water. So we are a water-dominated planet. And within that 70%, 97% of that water is ocean. So we are an ocean-dominated planet. And I think this is really good to remember because living on land, we sometimes forget that we're actually in the minority. We're living on land, and yet we're living on an ocean-dominated planet. So our connection to the ocean is very important and impacts our daily lives every day, no matter where you live. So that's Globe Toss. You can obviously talk about a lot of the science, but you can have a math extension as well to focus on things like percentages, probability, that sort of thing. So that is the first activity. Again, if you're just joining us, we are talking about the ocean literacy principle number 1. The Earth has one ocean with many features. You can access this activity and the next one on our education website. Just go and you can download this activity for free. The next activity, and this is a precursor, kind of a prep activity for what we are going to be doing next week. Next week, we're going to be focusing on sea level rise and how that dictates climate and weather and things like that. So we're going to do a very simple couple of density experiments just to show the different densities that we find on Earth and why that's important. So these activities are really fun, but what's the connection to the, just a little bit so you can see, what's the connection to the Earth? So we're going to do these, and then I'm going to show you the connection to the ocean concept. So all you're going to need for this activity is eggs. And I'm assuming that most people probably in their preparation to quarantine probably bought some eggs. So hopefully you've got some eggs lying around. You just need, you can use 1 or 2 eggs. 1 is just fine. You also need fresh water. Oh, excuse me, you just need water out of the tap, okay? And you're going to want to fill 2 jars with roughly the same volume. I know that these are different shapes, but they have roughly the same volume of water. And what you're going to, and you also need table salt for this activity. And I'm going to demonstrate it before I get too far in, what you would do with your students, how you would actually do this. So very carefully, now you can use tongs if you want to, use your fingers or a spoon, but you want the eggs to be raw. So you want to be very careful how you place the egg into the water so it doesn't crack. So you're going to take your egg here, and then I'm going to put it into solution 1 here. And you don't have to use food coloring with your water. I did that so it would show up on today's session. So I put the egg in this solution, or this water here, and the egg sunk all the way to the bottom. Okay. I'm going to put another egg into this solution. And as you can see, it's like fancy Easter egg dyeing. You can put the egg into this solution and the egg floated. Okay, so the egg, so there's obviously a different density in these 2 liquids. And density, if you remember, density is the ratio of mass over volume. Okay, so if you have a more dense liquid, it's going to be heavier than the less dense liquid. So by looking at this, which solution here is more dense than than the other one. And so you can actually have a conversation with your students about which liquid do they think is more dense than the other liquid. So one liquid actually pushed this egg up to the top. So the more dense a liquid, it's going to be able to cause things to float a little bit better than less dense liquid. So this liquid is actually fresh water with nothing added. This solution here has just about 1/4 cup of table salt mixed in. Once I added that salt, I created a very dense solution that was able to make that egg float, okay? It made that egg buoyant. That's why when you get into, if you compare yourself floating in a pool and floating in an ocean, you float better in the ocean. The ocean water is more dense than the pool water. So the more dense the liquid is able to make an object that has the same mass float better than in a liquid that is less dense. So you can do that with your students. You can also make a mixture that's kind of a mixture between the two and see that egg kind of hover in the middle and talk about that. You can do a lot of different things with this. You can have this just as an experiment so that they can talk through the differences they see, and you can talk about what you did, or you can tell them what you did. You can tell them that one is salt water and one is fresh water, what's going on. It's up to you, but it's just to show that that an object that has the same mass reacts differently in two different solutions of different densities. And so what's going on there? So what I'm going to do now, I'm going to remove this egg, and I'm going to show you another really fun thing to do. And I use different colors for this, and so bear with me. What I'm going to do is I'm actually going to mix these two together, and if everything works right, you're going to see the different densities between the salt and the fresh water, and then we're going to talk about why all this matters. So I'm going to very, very carefully add my salt water to my jar. There's nothing in this jar here. Okay. All right. So I've got my salt water here. And now, fingers crossed this works, I'm going to add very gently, I'm going to add my fresh water. Well, it didn't work, but what you should see is the fresh water would be on top of the salt water here. You would have actually a pretty decent layering effect going on here. So I sloshed it a little bit too much pouring it in. So, but you can do that, and so your students can actually see the layering of your salt water and your fresh water. Okay. So density. So when we're talking about density and why this matters is when we talk about the ocean and the ocean's impact on our daily lives. The fact that we have different densities with different bodies of water on Earth does matter. Okay, it makes for really fun experiments. It makes for really cool conversation, but it really does have an impact in our day-to-day lives. So next week we're going to explore this more with a really fun activity looking at sea level rise, melting ice, all sorts of stuff. But we're going to talk about density along with that. Most everybody has probably heard of currents. We talk about currents. When you go out into the ocean, you want to be careful of currents. It's that movement of water around the globe in a certain area. It's the movement of water. Currents move heat, they move nutrients, they move energy, but it's that flow of water. Currents can be caused by a variety of different factors, one being wind-driven. So if you're out at the beach and you see water flowing, and the wind is blowing, then you've got a wind-driven current. But there's another type of current called density-driven currents. And density-driven currents have to do with exactly what we did here. When two different densities of water meet in the ocean, so you've got an influx of fresh water coming in, meeting up with very full-strength seawater, there's a layering that happened that was supposed to happen with my experiment there. There's a layering that happens. The salt water sinks below the fresh water. And because of those two meeting and the two different densities, that actually can cause the movement of water, density-driven currents. And why this matters is these density-driven currents have a huge impact on our climate and our weather. So any change in that current, any change in the different densities that are meeting can really impact changes in our climate and weather patterns that we see. So density is very important, not only for the animals that you find. Certain animals live in certain densities of seawater. They can't withstand very salty conditions. They have to be in a little bit less salty conditions. So density has a lot of importance with not only plants and animals, also weather and climate that we see all across the globe. So next week, we're almost out of time, but next week we're going to talk about this in more depth. It's called the thermohaline circulation. It's a density-driven current, and it has to do with density, at least two different densities of water meeting, as well as temperature differences. And those two things come together and can move water across the globe, impacting our climate and our weather. So density experiments are very fun. You can find this. This activity is called Are You Dense? And it is found on our website. You can download this activity. There's also another activity that goes along with it using ice and rubbing alcohol, also looking at different densities. Very easy activities to do and a good conversation to have with your students and with your family or with yourself. So with that, I'm going to open it up to see if there are any questions, and if not, we will see you next Thursday, and thank you for tuning in. I will see if there is a, so I do have a question. Why do more dense liquids make things float more easily? That is because, it's a great question. The more dense a liquid, there's more of an upward force for an object. So there's more to push an object up to the surface, so it becomes more buoyant. So there are more forces acting on that object to push it up. So that's a great question. And that force outweighs the gravity that's pulling that object down to the bottom. When you saw the egg sink in this liquid here, the object sunk here because gravity was stronger than the force of the liquid pushing it up. More dense liquid has more of a force, more particles, more mass to push, to override the force of gravity that's pulling on that object to the bottom. So great question. Very, very great question. So that's why you see an object of the same mass reacting differently in different densities of solutions. So great question. All right. Well, if there are no other questions, thank you all for joining us. And if you have any questions in the meantime, feel free to email us and reach out to us with any questions on anything that we did, any questions on the concepts or the delivery of the activity, and we'll be glad to help you with anything you need help with. So have a good rest of your week, and we will see you 4 p.m. next Thursday. Thank you.